Okay, let's go ahead and get started. Welcome everybody to today's demo of PHENOM, generating integration code for data transforms using PHENOM. We have with us today Sean Foley, who is a senior engineer with Skayl, and he is going to be walking us through the demonstration. He is our resident CinC expert, CinC, which is our Configurable Infrastructure Capability. Today, we will be, as I mentioned, talking about generating integration code. And Sean is going to be taking us through a number of different features within Phenom, including bulk model import, deprecation, our template customization, path refactor, naive merge, take a quick look at the meridian map at one point. We'll be looking at the health check, which we've looked at in past demos, but we're going to be using it a little bit differently in some cases here. We're going to look at sync generation and also at editing the integration model, which is a little different than something that we've done in previous demos. So Sean, would you like to go ahead and get started? I'll pass this over to you.
I can do that. So let me start off with this picture to just set the scenario. So the publisher and subscriber here are going to represent our existing applications, existing messages. It's nice, it's convenient. They are communicating the same data type. Now for demo convenience, I've gone ahead and set up some other transporters that we will use later, but pretend these bottom three don't exist for the moment. We'll get to those later. So now we have this, and we need to integrate some new code, some new components. And because we assume they're face aligned, well, we have data models. Life is good, or at least better. But as we'll see, there's actually a bit more work that we need to really integrate those. I will get to why in a second, but let's take a quick look at some of the things that we do have. So we've simplified this to our trusty inertial states message. We have a subscribing UOP that accepts that as an input and a publisher as the output. I've actually gone ahead and filled in code to send and receive those. And we will see that those are happily communicating here. And now the question is, what do we need to do to add in our new components? So first things first, we need to get them in the same project, in the same space within Phenom. So what I'm going to do here is use a naive merge tool. So I can select my new data model. And this is representing something that perhaps I'm getting from other components, other UOC providers. And I'm going to import that and merge it into the model. So this is called naive merge because it's working at a very low level. Essentially, it looks at each XMI element. I think I actually have this in a window here. UDSDM. It goes element by element. It says, okay, in the existing model, do I have this GUID? Yes, no. If I don't have it, it's representing a new thing. It could also represent an existing element. And in that case, this override option can be useful to make those changes. We will use that in a moment. But what this is doing, it's just getting everything within the same space. So when this finishes, we're going to see some other UOPs, other data types. The conceptual data model is also getting merged in, and we're going to see how that's important in a second. If we look at the new model, we can show it in here while that is loading. It does have its own UOPs. So presumably in isolation, this data model has a new subscriber UOP that uses some of those data types. And then the question is, okay, we're assuming that these are, I will call them logically or abstractly comparable domains. If we had data models and you're trying to merge in and communicate an inertial states position, and also the status of a network operations center. Well, those are completely different domains. There's probably not going to be overlap. In this case, though, we'll see that now that these get merged in, we do have overlap in the domain that they're speaking of. So the new data types that we've merged in, we have an aircraft status, an object position, and a plane location. So I've used synonyms here to represent the idea that you can have components within the same domain. Again, the status of some flying thing, or the status, the position of an object, but the way we talk about them is different. And this is a lot of the challenge in merging these models together. The analogy I would make is we might be speaking of the same thing, but using synonyms for that. And the DSDM, the domain-specific data model, can be doing the same thing. If we look at how inertial states, we'll take this latitude, for example, these paths represent conceptual model content, and this is how the views are documented. So it's saying, okay, this latitude is an airplane position. Position would be the observable. In some of these new views, we have an aircraft status, and it's documented differently. It talks about an aircraft position. And object talks about some object entity's position. So even though the concepts are comparable, the way they've been documented is different. And we can see those different elements in the conceptual model, the aircraft, object entity, airplane. So some of the work that we need to do is being able to merge these together. If we don't do this, then a lot of the data transforms we've been talking about aren't even going to try to perform a transform, because the idea is to the computer, it's nonsensical. Just because you have some position doesn't mean you should do the transform. You might have your own ship position and a target position. Okay, they're both conceptual positions, but you definitely don't want to get those mixed up if you're translating messages, because they're not the positions of the same thing. And so that's why we're going to need to do this DSDM, this conceptual refactoring first. So we're going to be doing those in 4 methods. The first one that I will start off with, let's just go down the list, and we can say, okay, we've got an aircraft status and its ID. We need to make sure that this is documented the same way as inertial states. This aircraft element ID, we as a human can know that that's comparable to a vehicle ID, and we can actually go in either direction. We could change the documentation of inertial states to match aircraft status. We could change the documentation of the 3 new views to match the existing one. All that really matters is they're the same. Which model is primary? That's sort of a policy question that's up to the modeler. Mostly, we're going to be changing the new views, but as I was working on this, I actually noticed some of the existing one was misdocumented. I think the original model that I had loaded up was perhaps an older version. So to show that idea of sameness, well, I'm actually going to fix up some of this. So first of all, this altitude, I had previously, I guess, misclicked, mistyped something, and that says it's a latitude. Well, that's not right. So let's go ahead and fix that. So instead of being the latitude measurement, we can change this to our altitude here. We're going to either select a platform type representing this. So, okay, a float sounds good. And we can leave this path the same. It was really just the measurement that was wrong here. So we can save this. Another problem that I found was that this vehicle ID was maybe not wrong, but older. So I made my life inadvertently a little bit harder here, because the original model that I had loaded was using FACE 2.1 based SDMs. And the one that I naive merged in for the new content is using 3.0. And the way that identifiers were represented changed a little bit. So instead of this unique identifier, there is in 3.0 land, there is a different one, identifier. So we're going to change the original model to update that so that they're going to be the same. Again, we could do these in either direction. I'm just editing inertial states to emphasize that. The platform type can be a long, and for this path, we were originally an airplane unique ID, and we can stay that. So we fixed up a few things in the older model. Now let's move on to some of the newer data types. Again, note this difference. The original was using airplane, and the new ones are using aircraft. We know they're actually the same, so we could say, okay, let's take this ID. The observable is right, the measurement is right, the representation, but the conceptual documentation about the meaning of this, the semantics, the context, that's what we need to update from aircraft to airplane. So we can pick this one. Note this is the same that we just used to update the inertial states vehicle ID. We can save that. And if we wanted to look at some of the progress, that's, as Sonia mentioned, our meridian map earlier, just a graphical way to see some of this overlap. And we could see that now these linkages represent things that are documented as the same type at the conceptual level. So these are both airplane unique IDs. These others are representing fields that we haven't yet updated. We're going to see in a bit how we're going to get more connectivity between our older and existing messages. So that was method one. That's what I would call the field by field, or maybe the normal approach. If you're adding an attribute, adding a view field in Phenom, you're probably doing something like that. So we could go and do the same things for our altitude, latitude, and longitude fields, but I wanted to show a different method. So this is going to be number 2, and this is involving deprecations and more bulk refactorings. So if we're saying, hey, this aircraft, that's fine in the new model, but I really want everything to be documented against the airplane entity instead, I can actually deprecate this. I hit delete, but Phenom detects that things are using it. If we literally just deleted that, it's sort of like a dangling pointer or an invalid reference. So we deprecate it instead. We get a warning about that when you're viewing a node. And one of the things that this deprecation does, when we have fields marked as deprecated and they're being used, there's a health check that shows these. So the idea of this is that because we don't want to just break the model by deleting things, I've used that approach in the past at the XMI level. You delete a node, then you try to parse the XMI, and your XMI parser says, hey, there's a platform type or a reference to this GUID that doesn't exist. And it's almost like when you're coding, you can make a mistake, the compiler tells you where all of the errors are, and then you can go fix them. It's a similar idea with the deprecation. We deprecate that, and then we can look at the things using it to go and try to fix them. So this is telling us that there are characteristic projections or path documentation for these 3 fields. Those are the ones we were just looking at in aircraft status. And we have an option to fix them. So these are all using the same path. This gives us a bit of information about the view that is containing those fields. In this case, there's just one. And we have an option to say, okay, instead of using this old path that has deprecated elements in it, we can change all of these to say For each of these that was using aircraft dot position, update those to use airplane position instead. Again, this is because we want to match the original data model in our inertial states message. So we can save that, proceed with this fix up, and we see, okay, those paths have automatically been refactored, and we can run the health check again to see that. That's fast, we might as well do that. And then we'll go look at the node in a second to see that that took effect. So now we see that we don't have any of these deprecation issues. So let's make sure that that worked. If we look at aircraft status now, note that all of those aircrafts were redocumented against airplanes. The older style, we would get a little warning there saying that there is a problem with it. So for this view, we're done. We've taken all of the fields, we've redocumented against the existing model. And so now we should see that show up in our map. And note that we get these extra fields. So for the altitude, latitude, and longitude, these fields were not mappable against inertial states. And the other way we could see that is actually looking at the paths in this table. So this takes us through 2 methods out of the 4. We saw manually editing this field by field and changing the path, as you would when you're editing normally. And we saw deprecating one of the new conceptual entities, which allows health check to find those instances where they're being used and change all of them at once. So now for the next 2 methods. So we have 2 more views here that we need to be updating. The one I want to show here is going to build on that naive merging. So let's go and generate an XMI model. So I mentioned earlier that the naive merge could also edit and make updates. So what we're going to do here, we're going to say, okay, this is the current state of things. I know what it needs to be, so let's go and edit it in the XMI. Then we can re-import that and ask Phenom to overwrite instead. So let's find our view. This was object status. This was not object status. This was object position. And we want to take this ID field, and remember the idea here is that we want to remap this and say, instead of being documented against the newer conceptual object entity, we're going to change that and be against the airplane entity. Conveniently, we just did that for aircraft status. So if we find that, we actually know that this projected characteristic and this path are the ones that we want to use. So I'm going to cheat and take this, make sure I'm on the right view down here, object position, and changing its element ID to match the one that we just did. If I didn't know that, well, we can always follow the GUIDs. It's not easy or very fun, but if we wanted to, we could figure out which of these is representing the platform realization of airplane, find its role name as a composed element of that, and that's where we could get this path from. But since I know that we just updated the aircraft, aircraft status to do it, that's how we know that this path and this projected characteristic are also going to be valid for this refactoring. So I think of the XMI, it's kind of like the source. One of my favorite sayings is, with the source, I can do everything, but I can do everything eventually. So in theory, we could do the same approach, use the same approach for these latitudes and longitudes. One of the issues we would run into, though, and let me show this in Phenom because it's a little easier to see there, is that these views are actually documented slightly differently. It's not just a conceptual difference, but if we look at, say, this latitude in inertial states, and I'll look at the latitude inside object position, they use different measurements. So this new one is using degrees. The inertial states latitude is using radians. This is important because of the way that realizations work within the phase model. All of the platform and logical entities and composed characteristics are traced back to a measurement. So I can't just copy the same path that I had in aircraft status, because at the logical level, this composed characteristic points to the wrong measurement. If I change this here to match the same position float, well, that determines the measurement that is being used. So what I would actually need to do is go and make new logical realizations of airplane, change their types to point to the right measurement, then make platform realizations of those elements, and then change this path to be at the platform level. I've done that before. It takes a long time. It's not very fun. That's one of the reasons at Skayl that we built tooling around this, because it's tractable, but well, there are easier ways to do it. Let's use tooling instead to do that. But I did want to present that as an option. Again, the XMI is like the source. You could eventually do everything, but we've just refactored this ID field here. Let's get that back into Phenom. So what we will do, we will use our naive merge tool again and select this edited file. We want to make those updates, so we're going to check overwrite in this case. And what we should see here when this is done is that the object position ID field has been updated. And there we see previously all of these were documented against object entity. Now this one is airplane's unique ID. So that's method number 3. You export the XMI, naive, make changes out of band and merge that back in. For our last option, our last method, we're going to change these object entities for the rest of this field. And we're actually going to cover both of these views, object position and plane location, the same way. So one of the features in Phenom, it's sort of like, at a high level, it's sort of like a naive merge, but it's a bulk import feature. And this lets us read in CSVs that have well-defined or well-known headings representing different attributes. So what we're going to do, we're going to export or generate a CSV that matches something that we can re-import. So for this, I'm going to make a new template. We'll call it dot, and this will be a CSV. I have the contents of this saved off over here for what that should be. So this is essentially FreeMarker. That's a template modeling tool. So it gives ways to do lists, tests, dotting into elements and structuring this. This structure is pretty simple. It's just, comma separated values, but we also use this for a lot of the code generation. So I will save this, my template.csv, and we can do a model generation based off of this user template. If If we open that up, just extract that here. So this is kind of the raw data, and not quite XMI level. It's a little friendlier than that. We're using a lot of names. We're able to filter out to see just the information we want, but it's kind of a raw data of these fields within the views. I didn't do any down selection, so this also has all of the inertial states views. We don't need to update any of those. I'm just going to get rid of that, so we're only working with the things we need. But if you had other reporting, you could also use user templates to do things like that. Here are our two views that we have remaining to document. This line is representing the one that we just did via naive merge, and these are representing the ones we did with the other two methods, that is the field by field editing and the deprecation based editing. So what we can do here is say, well, we know what the answer should be. We want these to be airplane unique IDs. So instead of, for our lat and long position, I'm going to overwrite those. For this one, they were very confused. They weren't sure if it was a bird or a plane or a superclass, but we're going to make that airplane unique IDs. Sorry, not unique IDs. That was wrong. These should be positions. These two will be positions. This one needs to be a unique ID. I think I messed up some of those when I was talking. I will be quiet and look at these for a sec to make sure. Yeah, this one is wrong. Whoops, this is a position. So our ID is saying it's an ID. Our latitude and longitudes are saying they're positions and positions. Great. When we re-import, we actually don't need these primitives and measurements because the platform type actually embodies those. The platform type determines what the primitive is and realizes a measurement. So this is nice for information, but we don't need it when we re-import. Also, since aircraft status, we were just using that for reference. We don't need to update those rows. And this ID row, this is the one that we had done via editing the XMI. So we don't need to change that one. So these are our remaining views. Object position, its latitude and longitude. Again, we didn't want to do that via XMI because it's using a different measurement using degrees, as is our plane location. But we're showing our fourth method of using a bulk import that can update based on this CSV representation. So save this. And back in Phenom, we're going to do an import. It's view characteristics that we're changing, and we want to update them. It's also a good way to import new content, but in this case, we do want to overwrite things that are there. So we pick the update option. This is our write CSV. So we've imported those changes. And again, if we wanted to see that they've taken effect, we can look at these views. Note that we all have airplanes here. Note our measurement is preserved. Unlike, that's why I didn't want to change in the XMI, but we're preserving the measurement. These are degrees, as is the object position. But now everything's documented against airplanes. And we can see that here, that we get a nice mesh. These are our new views, and we see that all of the fields within them are connectable to inertial states. So stepping back a bit, we started here, existing publisher and subscriber. We have some of these channels and transporters set up. We'll use those in a moment, but we've imported a new data model that has a different conceptual model and extra views. Those views were documented against their own models. You could imagine if you're, maybe a component provider, then you don't necessarily know who's going to be procuring that. So you model it against your own models. Similarly, if you're an integrator, there's no guarantee that all of your component providers, all of your vendors are going to be using the same model. So even though they're talking about the same ideas of an airplane, an aircraft location, the way they model those might be different. So we need to align those before we're able to do any kinds of conversions. So the next step, I'm going to build out this integration model a bit more. So what we're going to do, we have this context, again, some of that was set up for the old one, but we're going to need a main program and a UOP instance for our new UOP. So we can create a new main program. Let's call that new sub main. Save that. We can make a new UOP instance. And this will be pointed to the UOP and the imported data model, enable all of those message ports or connections, and associate it with the main program that we just made. So with this in hand, we can go to our integration model editor. We'll load that context. We'll get our new UOP instance on here so that we can connect it up. This is why I'd made these transporters earlier. We could have made them now, but they're really the same things as this one. So they have a channel that will specify the, in this case, UDP properties, IP addresses, and ports. But the more interesting part is the transform that we're going to put in between those. So after we're going to have 3 of those, so we're going to route through this transform to each of the message types that we just refactored. That's our abbreviated here, but aircraft status, object position, and plane locations. So we'll do a transform for each of those. A little bookkeeping, we just need to name these and say what their input data type is. Okay, so we've saved that. Now we can go and see what happens if we generate using this. So I'm going to pick, we just want the new main program, phase 3 CinC, and this main. So let's open this up. And the thing in particular I want to show these files contain the conversion functions that CinC generates. So let's open up one of those. Some of these are probably expected. So, this one looks happy. Notice in these others, though, we're actually not getting the extra fields. We're getting the IDs. We documented those semantics to match. We saw in Meridian Map that the semantics of the other fields were matching as well. But remember how I said the measurements were different. So because the measurements are different, when we're trying to generate an automatic transform, we recognize that they're different measurements. So we need some way to convert between them. There was nothing in the model found to do that, and that's why we don't see conversions for these other fields. So broadly, you could think of this as really high level 2 steps. One is the conceptual model alignment, where we're using the same vocabulary, the same primitives. Everyone's saying it's an airplane's ID or an airplane's location. But that is necessary but not sufficient. Other levels, such as the measurements at the logical level, also need to be aligned or converted. So let's go and do that. So I will close this, and the way that we can add these in, we can actually do a similar thing as the naive merge earlier. I'm just going to generate this model. Open that up. And we need to add in a few measurement conversions. So I also have these tucked away. So let's, the way conversions are represented. So face does have the concept of a measurement conversion, which is saying this is like our source and destination measurements. The contents of the equation field is not specified. We use this sort of syntax to represent kind of C-like, and well, dest and source represent the destination and source view fields. During CodeGen, that gets replaced with the actual names. So we're going to take these, put those into this data model. In this case, for the demo, we're not too concerned about where they go. Well, we will at least put them in the logical level. That's sort of where they belong. And now we can do another naive merge of this file. We're only adding in this case, so we don't want to overwrite anything. So that's finished. So now those conversions should be present. We're working on making those viewable in Phenom. I don't think we can view those quite yet. We can see that they exist here. So they did get properly merged in. We can't look at their contents yet. But if they're there, the transforms when we do CinC generation should be able to take advantage of them. So now let's go ahead and regenerate CinC again. So I'm going to extract this onto my Linux VM to build that. Okay, this is extracted down here. We could go in and build this now. It won't be terribly interesting yet because this freshly generated UOP doesn't really do anything to the data. So I've prepared some code to print that out. So what we need to do is just edit that UOP's code so that it actually does something. That's going to be in this file. Our do periodic, as you can see, is empty. So we will take this code. All it's doing is going through and checking, okay, trying to receive all of these messages, the aircraft status, our object position, plane location, and printing out what it's getting. So I'll save that. And now we can build this. So on the left, we have our original publisher. Notice we're in a different directory here. So these are completely unmodified. We don't need to change those. The way that these transporters were set up in the integration model, that's one reason I had those set up already. So even though nothing is listing, this publisher was already set up to send over the right ports so that our new subscriber is going to be able to get it. Start up our existing ones. And here's our new one. And we can see that, I'll just put a few breaks in here to see a little easier, that those are taking effect. We get the same ID. Our altitudes were all the same, but notice our lat longs, some of these are degrees and some are radians. So what we've shown here, again, those two large pieces, we've aligned our conceptual models. We've added through 4 different methods, manually changing things, deprecating entities, and using health checks to refactor them. Naive merge by exporting the XMI, editing that, and re-importing it. And finally, using a CSV export, editing those fields and doing a bulk import there. So 4 ways to do that. After the conceptual models were aligned, we went through and added necessary measurement conversions using some of those same tools with the naive merging in the conversions, updating the integration model to put transforms in so that when we do code gen, it looks to try to find transforms, and finally generating our new application that has that is subscribing to 3 new data types that we've just aligned and mediated. So that was what I wanted to show, Sonia. Are we taking questions, or did you want to show anything?
Yeah, absolutely. So, can you explain the templates more? Do users have the ability to create their own templates? Does Phenom come with preloaded templates, or are the templates something that users must create?
Sure, good question. So there are a few preloaded. A lot of these came from, say, reporting or things, ICD-based reporting, descriptions of content. So some of these are prepackaged. Some of these, unfortunately, I'm not exactly sure which ones are. I do think most of the ones in green are prepackaged with a few exceptions. Since I'm working on my local instance, I know some of these are just things that I was playing with earlier, like bad enums, I think is, from the name, I'm guessing not a prepackaged one. I'm almost certain Moo is not a prepackaged one. And I was doing a little more testing for some of these. So these, view comma export, it's my template we just made, and my view field template. I made these when I was rehearsing for this demonstration, but I believe most of the others here are prepackaged in Phenom, and there should be documentation on the knowledge base about what the available sort of what the model or the free marker input is. So okay, how do you know that struct has a name, or a field called fields that has types and other things like that. But you can also create your own, as I just did earlier.
Okay. And knowledge base is our user resource for guidance in using Phenom and generating code, etc. Thank you, Sean. What about other types of transforms, such as Cartesian coordinates and other measurement systems?
Ah, good question. I was actually hoping to show some more complicated transforms, I realized that the view I started with makes some of this a bit difficult. So I'll give an example. The transform that I wanted to use was something like an ECEF transform, where let me see if I still have that around. I might not have that transform around. Well, okay, I can give you the rough idea of why that was difficult. So if we look at the input, the input views or the source here, notice that altitude, latitude, and longitude are all using different measurements. So each of these measurements, and well, we can look at one. Each of these measurements has a single axis. Meaning, it's not just saying there's a position and I am the x-axis, or it's the same position, the same system, but I'm the y-axis. There's actually a separate measurement system for longitude, latitude, and altitude that all have one axis. This makes it difficult because to do the ECEF transform, roughly what it looks like. So this is very much pseudocode here, but suppose our input is like lawn, and we and again, these are all different measurement systems. Well, the output for ECF, it's basically x equals lots of math, but it's a function of all three of these things. And because they're different measurement systems, there isn't a good way to express that within FACE, because we get one source and one target. Well, which measurement or measurement system do we include? We could say the source could be one of these things, but there isn't really a way to say, possibly an extension might be the source could have, maybe you have multiple sources or multiple targets. That might be an interesting way to extend conversions to be able to define things like that. That's why I couldn't do a more complicated in this one. If I modeled these a bit differently, so let's say the inertial states had been an IDL struct instead, where we had altitude, latitude, and longitude bundled inside of an IDL struct, and this IDL struct realizes a single measurement and measurement system with three axes. Well, in that case, I do have a source, a single thing I can point to. I can point to, the whatever. I guess that might be just a general WGS84 position, and it might have a latitude measurement axis or a longitude measurement axis, and this gives me things I can plug into this function. But the data types I were using, they were not modeled that way. They do have completely separate measurements. So that's why we couldn't do that sort of conversion. But we're definitely thinking about it. Another way might be to have an extension to the face measurement conversions that allows multiple sources or targets, or perhaps ways to assign equivalents to say that the position latitude measurement axis within a WGS84 position measurement is equivalent to this WGS84 latitude position measurement. That might be another way to affect some of those more complex transforms. But a lot depends on how the content is modeled.
Okay, great. Thank you, Sean. Thanks for taking us through that. I think we've got time maybe for one more question here. We saw a fairly lengthy list of file types for export. What file types are available to Phenom users?
So I can go through some of this list, and let's see. So some of these are, maybe I call them historical in the sense of they were useful at one point, but some of them were just for particular projects. So I'm not sure that all of these are the most useful. So the XMI models, those are probably the most commonly used. These HTMLs, docx, those were for some fairly specific use cases. We are looking at ways to make these more customizable. You could say generate Word ICDs or things like that. The UML, I haven't seen that one used very often. IDL export, Base 3 sync. These were probably the ones I'm using the second most these days. So we're working a lot with CinC, as we saw, generating transforms. Mock UOPs, I believe we had another, maybe a month or so ago, another demo all about mock UOPs. So this can be a convenient way, if you, almost like a mini SDK for Face, you've got a data model and you want to get up and running real fast with some code. The user templates we saw, some of these others are for our older TS. We should probably actually be removing some of those. This one, I believe, was in development, where we can generate the transport service APIs, but we hadn't had the CinC implementation under there. Now that we actually have CinC, I'm not sure that this one makes the most sense to still be having, but that's a quick rundown of the file types in the list.
Great, thank you, Sean. So thank you all for joining us today. Sean, thanks for taking us through that. We really appreciate everyone's time. And we had some good questions there. We do have some webinars coming up. We've got our Architect and Integrator webinars coming up for safety certification on the FACE technical standard. That is going to be Wednesday, September 1st at 12 Eastern. And then we have the value proposition of MOSA on Wednesday, September 29th at noon Eastern time again. So we hope that you all will be able to join us for some of those, and feel free to contact Sean. His email is Sean, SHAUN, @skayl.com, or any of us here at Skayl, or go onto our website, and you can also sign up for a free face alignment gap analysis or a more customized demo at skayl.com/conformance. Thanks so much and have a great day.